When you ready?
Yep.
Okay. Good morning. I'm Peter Lang from Chevron Glass. Chevron Glass are industry suppliers and processors of glass. So we polish glass, we toughen glass, we make custom laminate, we make double glaze units, that sort of thing. So we don't actually manufacture glass, but we take raw glass from Pilkington or from Viridian out of Melbourne generally, and then we process it from there. So we do things to it. We also buy a bit from overseas, but generally we try and stick with Australian product. The talk today is really about glass facades, so it's about different facades and how they fit into the building structure. We're not experts in facades, but we're experts in glass, but we know enough to be able to give you an idea of how it works. There are three basic types of glass. Monolithic glass is the glass that we get straight out of the float plants, out of the manufacturing plant. So it comes in monolithic, meaning one, of course. So a single piece of glass, we get single pieces of glass delivered to us, and then we'll process it from there. So we will make laminated glass. We also buy laminated glass from Viridian as well, from Melbourne, because they can make it cheaper than we can make it. And we toughen glass. So toughen glass is probably the most important thing we'll probably discuss today. But what I can do is show you a sample of some toughened glass. You've probably seen it before. You may get a paper cut from it, so just be a little careful.
Yeah.
That's what it looks like when it's broken. So it's about 5 times stronger than normal glass.
It looks like crystals, doesn't it?
And when it does break,
pretty.
it breaks in little granules.
Yeah.
So you've probably seen it on a current affair with exploding shower screens and all sorts of things.
Yes,
But
yes,
I've
yes.
had one of
yes.
those.
Generally, the glass is extremely strong.
Is
And
that what we call safety glass?
It's safety glass.
Yeah.
Yes.
Okay.
Actually, you can see on one side it's got a slight. You see how it's shiny on one side, and then
Yep.
it's like got a little bit of a pattern
Pattern
to
on
it.
the other.
Yeah.
Yeah.
Is that
Yeah.
like a sheet of something?
In
or?
the well, that one's pretty cool. That one is a patterned glass. So that's something like a bathroom glass.
Got you. So that
Yeah.
is
Oh, yeah.
that's not
Yeah.
typical
Yeah.
to safety
So
glass.
I
That's
didn't even know that
special.
was there. No one's ever
Yeah.
picked that before.
I've just picked it up.
So-
Yeah.
So
Look at the drawer.
Because all I've done is gone into the bucket and picked out heaps
Yeah.
of granules.
Yeah,
and
yeah,
thrown
yeah.
So
it.
with even though it's quite strong, Peter, is that kind of like shower screens? I've heard like shower screens can be quite weak around the corners, the edges,
Yes.
and they have to be like super careful with
That's
installation.
right. Yeah, toughened glass is extremely strong on the face, so you can hit it with a hammer. You can kids run into it all the time. Like, tennis balls, cricket balls. Obviously, squash courts used to be made out of toughened glass with exposed edges.
Oh.
But where toughened glass is a bit weak is on the edge. So if the edges are damaged, and sometimes with a shower screen and exploding shower screens, sometimes you're dragging it across tiles. It may not break straight away. It may take a week, it may take 2 weeks, and then suddenly the panel will break. And of course, the report we get is that panel just blew up. Nobody was anywhere near it, but it's because of the damage that was caused earlier in the process.
And even in transit, then when they put them on the vans,
Yeah.
that's important to not
Absolutely.
wrap something around the edges. Then you've got to sort of secure it at the face.
Yeah, that's right. We always clamp to the face, and we always use rubber underneath. So if you were to get a piece of toughened glass and whack it on a piece of concrete, chances are it's going to break on
Yeah.
If you whack it on the carpet, you'll probably be okay.
It happened to one of the other lecturers here. He was putting in a shower screen himself, and it was him and his wife like picked it up, and obviously they didn't pick it up at the same time. One picked up one end and one picked up the other.
Yeah.
And when they were putting it in, the whole thing just exploded on them.
Yeah.
Sort of thing.
Huge sound.
Yeah, it'd be quite scared because I got one put in mine, and it's it's 2100 high,
Yes.
sort of thing, like whatever thick,
Yeah.
and the builder was kind of like, I'm afraid to touch this. I said, just be careful, don't knock it on the corners anywhere.
That's right.
Yeah.
The corners are the weak point.
Yeah.
Right. We make it by cooking normal glass at about 600 degrees. So we cook it for about 4 or 5 minutes, depending on the thickness of the glass. We then put it into what we call I forgot what it's called. Into like almost freezing it. So it goes into ambient air temperature. So it goes into the quench. So the quench doesn't have cold air, but it has air forced over the glass. So that changes the temperature from 600 degrees down to about 25 degrees in about 20 seconds.
Wow.
And what that does is changes the molecular structure of the glass.
Make it
And that's why it's so strong. It's in tension on the outside and compression on the inside. So when it breaks, it shatters.
Wow.
So a lot of people call it exploding. We'd like to say it spontaneously breaks or spontaneously fractures.
Yeah.
Because exploding is so emotive.
Yeah.
And it sounds
Yeah.
like an explosion. And sometimes it can be what it is.
Yeah.
Even though you generally only get a paper cut from it, when it does happen to break and go poof, you can get
Kind of a small, yeah.
small.
So it's obviously designed that way not to break into large shards that could actually like
That's
cause
correct. Yeah.
incredible
That's right.
injuries.
As a toughened furnace, the only way to know that a piece of glass is toughened is to break it. So we break panels 3 or 4 times a day, and there's a test. The Australian Standard calls for you map out a 60 mil by 60 mil square, and you've got to count the number of pieces in there. And generally, it's about 60 pieces. So we go 60 by 60 pieces. That meets the standard. So and you got to do that in 3 or 4 spots.
Wow.
So we do that 3 or 4 times a day to make sure the furnace is actually working correctly. Because the worst thing you want to do is send out glass that's not toughened.
Yeah.
That'll be a problem. But it does make the glass extremely strong, which is why we tend to use it so often. We also put it into toughened laminates. So we toughen the glass and then we'll laminate it back together again. We use that for a lot of purposes, balustrades, all sorts of things, glass roofs mainly. Anywhere that one of the problems with toughened glass is it does break and it falls from 20 metres in the air. It's going to hit you on the head and hurt. So by toughen and laminating the product, putting it both together, the glass will actually stay together and it won't fall. So that's why we do it with balustrades, and especially with glass roofs.
And that's because there's a sheet of material in there as well.
That's right.
It's not just 2 pieces of glass laminated together. There's a sheet of
So is that internal? Is that sheet inside the glass, or is it on just one side?
No, it's inside the glass.
Right.
Both glasses are sandwiched together, so it's a sandwich with the interlay in the middle.
Right.
This demonstrates it. This is actually a security glass that we've designed, that we've come up with. You can see we'll go out and we'll break the glass. You can see it shatter like toughened glass does. You'll find that they can't get through the interlay, which is what it's designed to do. That's not normal, but maybe I'll go back. Maybe I'll go back that way. And do that.
Just there's a play button down to the left
Is there?
of the chevron glass.
There is too, isn't there?
That jumps to the next
Good,
one.
right, that's just
That one. No.
There's another one just right
There?
there. Does that give you options?
No, it doesn't.
right clicking.
No. Oh, we're not going to be able to see it, I don't think. What's that?
There's probably a link we can go to.
There probably is on the web.
Yeah.
I'm sorry it didn't work.
That's fine.
It worked in practice.
Yeah,
Everything
it's
works in
always
practice.
the way, isn't it?
Yeah. I might be able to show it to you later because I've actually got the video separate.
All right,
So
okay,
I might be able to
yep,
show it to
yep.
you a little bit later. We'll come back to it. When we're designing glass for anything, we always ask architects or designers whether it's 4-edge supported or 2-edge supported, because we're looking to know what the span of the glass is. So 4-edge supported means it's 4-edge supported, and 2-edge supported means it's only 2 edges are supported. I've got that as well. No. So unlike when I spoke to an architect once, I said to him, you told me this was 2-edge supported. He said, yes, it is. I didn't understand what you meant though.
No.
So 4-edge supports means there's a framing system all the way around on all 4 edges. 2 edges means there's 2 edges.
So if you look
that's
at like
the
a
reason
glass
why.
balustrade, for instance, which is suspended a little bit off the
Yes.
floor of the balcony,
yes.
it's a 2-edge support.
Yeah, often balustrades are 2-edge supported. Yes, they are. Glass roofs are often 2-edge supported, which is what he had. Of course, he couldn't use the thickness of glass. He had to beef up the thickness of glass because he only had 2 edges supported. That's what he was upset about.
So what was supporting the other edges, like
Just waving in the
connected
breeze.
to?
So you need to design the glass to be thicker
Yeah.
to take the loads.
Yeah.
for someone to be able to walk on it, or the wind.
Yeah.
There's some examples. This is the Bolio building down here on Marion Road.
Ah, yes, another one, yeah.
Yep. So that's a 4-inch supported system. It's a flush glaze, so we'll go through flush glaze in a minute. Actually, no, we'll do it now. A flush glaze system. That's Bunnings red. That's the Bunnings framing. That flush glaze means the glass sits at the front here, and all of this is just peripheral. And they generally put a cap on that, so you'll see a cap or something on the front. So the glass sits in there with a rubber both sides, or they can silicone it, they can wet seal it.
Okay.
That's also a flush glaze system. So the glass would sit there, and then there would be some sort of capping that would go across it to lock the glass in. So that one there's only for thin glass, because the aluminium cap would probably finish there somewhere.
Right.
In fact, we'll go through it here. So that's the St. Lucia suite. Not many. We don't see St. Lucia used very often anymore, mainly because it's difficult to join. It's difficult to make a frame out of and to get the angles. But where we do see it used is a lot on glass roofs a lot. So they actually stick that to the steelwork. They put the glass in, and then they put the cap on top, and the glass sits in the middle.
Ah, yeah.
It's nice and neat.
There's rubbers generally go in these little channels here. All rubbers go in there, so everything's nice and tight and water sealed. Sometimes I don't bother using the cap. Sometimes I'll just fix it like that, and then they'll just structurally glaze it with silicone, and that'll also stick the panel down. Some architects like the cap, some don't. Some prefer it to be just flush. And that's a typical drawing from Capral, and you can see pretty much that's that bit there is that bit there.
Ah, yeah.
And you can see the rubbers both sides. The centre pocket system is probably the most common. I think these are centre pockets here. All these
Yes,
glazing here, all centre
yeah.
pockets.
Yeah.
This is 4-inch supported again. And a centre pocket system is basically that. So the glass sits in the middle, and you see this on lots and lots of shop fronts. The majority of shop fronts would be this, although architects prefer the flush glaze system with the glass at the front.
And it is, well, yes, where it's a partition wall, there's both sides of the front, and is that the only reason they've used the
You
middle
can
one?
span it a bit further, so you can span this, because there's so much more aluminium to it, you can span it a little bit further than you can with the flush glaze. It doesn't perform as well with the energy, so that's why flush glaze is a bit more popular, I guess, because because there's not as much aluminium. The more aluminium you got, the worse it performs. The more conductivity you get, so the heat passes through it easier.
Sorry, what was that one called?
Capral call it 400 series or narrow line, but it's a centre pocket. So there's lots of different manufacturers now of aluminium. So it's a centre pocket system. A few years ago, Kingswood Aluminium, one of the first in Adelaide to bring in a system of K-wall. So K-wall is there. It means Kingswood Walling System. So that's what it stands for. They bring all the aluminium in. Everything comes in from overseas, Thailand. The glass is generally out of China or somewhere out in that vicinity. It comes in flat like that. It's all toughened glass. So toughened glass, normally you never travel glass flat, but when it's toughened, it tends to dry better in boats. So they can put double glaze units into these systems and ship them over here and get them off with forklifts. They work by. I'll put this down. That's bolted to the slab of the building. So that's bolted to the slab of the building, like that. So you bolt it down with tech bolts. That's fitted to the aluminium system, and all they do is walk along. Put a little screw there. They walk the window in. They've got a little robot normally, a sucker with suckers on it, so it sucks to the thing. They bring the robot in, and they simply lift it and slip it over like that.
Okay.
So then the window's in place that quickly. So there's no screwing. There's no screwing of the window to anything, and they can go along as many times as they like, pretty much, until they need to fix to a structure.
And the window is attached to the face of that plate.
That's right. So the windows are to that plate. This has got a little bit of adjustment there. You can see it's got slots, so they can adjust it back and forth if they need to, and that screw there locks it in.
Wow.
It's a great system. It's not so good for the Australian industry, I guess, because they can now bring in windows and install them really quickly. The big trick with this system is they need to predetermine the sizes. So they have to go from a datum line on site. They have to be able to say that the builder has to be able to say to them, we're building to that datum line. These windows are going to fit, because if you're 50 mil out, they won't fit. So if the builder's out with his measurements, then they're in trouble. And that's happened before. This is a two-edge supported system. So I don't know where that picture's been taken, but I think the glass is actually curved there, so you do get a little bit more strength from the curved glass. It's only silicon butt joints, so the glass needs to be designed to have the thickness to be able to take the wind loads and the human impact for that support. Because without a mullion there, you know what a mullion is? Yep, everybody knows what a mullion is? Mullion, a framing system, yep. Without a mullion there to support it and give it strength, the glass has to give it the strength. So these are generally designed by engineers to actually take the wind loads and take the human impact loads.
How thick would that glass be then?
That's not very high, so that's probably 1,800, do you think?
Right.
Maybe 2,400. So I would have thought it would probably be in the vicinity of 15 mil thick.
Right.
Yeah, whereas if you put mullions there, you'd probably be able to get away with 8 mil.
Right.
So that's the difference.
Yeah. Didn't you, my memory serves me correctly, were you guys involved with doing the Apple store in the city? That was like because that's got the same thing. Doesn't have any mullions, basically. No. It's just silicon, and it's quite tall, isn't it?
Yeah, it is. Yeah, no, the Apple stores, that glass is too big for Australia. So it's all been imported.
Right.
So I don't know who even installed it. Apple, all the way in the world, do that sort of thing. They love glass, and they love frameless glass. So they've got frameless glass steps and...
I know Norman Foster designed their new headquarters, the Ring headquarters in California, and they insisted it had to be a single piece of curved glass. They didn't want any seams on the glass, and I think within the first couple of weeks of moving into the building, they had to call out the emergency services because so many staff kept just walking into the glass, and they won't allow anything to be put on the glass to warn. This glass there, people were sticking post-it notes on it, and they were told to take them down. And they had people like with head injuries because they were just walking along and bang straight into couldn't see where they were going.
It's a problem.
Fantastic design, but probably not too practical for people.
In fact, go on. Sorry.
No, you mentioned too big for Australia. What is the largest?
The biggest piece of glass we can produce in Australia, toughened glass in Australia, is about 6 metres. Now, I'm not sure about the Apple store in Arundel Mall because that may be under that, so that might be we may have been able to do that here, but certainly the one in Sydney we couldn't do.
Oh yeah, that's 2 stories or something. Two stories high, that whole facade. Yeah.
And are you saying that 6 metres is only a 2-sided support piece of glass for Apple?
It's thick though. It could be triple laminates, so there could be 3 pieces of glass laminated together to give it the thickness.
So when you say that, what's the thickest that one pane of toughened glass could be to then be able to think, well, I have to now laminate to get the thickness?
It depends on the wind load, but if you had to use the biggest, the thickest piece of monolithic glass we bring into the country now is 19 mil.
Okay.
So a 19 mil piece of glass, say in Rundle Mall, would span, I would have thought, 4.5 metres.
Yeah, with a 2-sided support.
That's right. But if you had to do that at Mount Lofty, that would only be about 3 metres.
Yeah.
It's a huge difference in wind loads. So it depends on what wind load is. Both would do the human impact, but the wind load's important. Speaking of Mount Lofty, there we are.
Ah, yes, the visitor
So,
centre.
I haven't been up there for 100 years, I think, but this was done when they after the fire. Remember, they had the fire go through Mount Lofty and burn everything down. This was rebuilt. They wanted to do what we just said, just have no fins, or no mullions, but they decided they couldn't afford it, and they ended up going with glass fins. So I don't know if you're probably not a great.
So they kind of like at a right angle to the actual glass,
That's
isn't
right.
it? Yeah.
So it's acting as a mullion.
Yeah.
So and generally fins are 19 mil. They're generally always monolithic glass, and they're generally always annealed glass, not toughened. Generally. Except in this case. These fins are actually, it doesn't matter whether the fin's internal or external, because it's the silicon, pretty much it's the silicon and the silicon bite you're getting that's actually giving you the structural strength of the mullion. So this one here, they've actually had the fins pointing outside. This is the plated building in Elizabeth. And they've attached shading devices to the fins, which is a really cool idea. I've never seen it anywhere before.
It looks quite nice too. Actually, it has quite a nice. There's a quite nice
It's a
look
great
to it.
looking building.
Yeah.
It's unusual to see such a great looking building in Elizabeth. Does anybody live in Elizabeth? Not offending any Elizabethians?
No.
Yeah, I thought it was a great idea. The architect was a very smart way to do it.
And that's why it's tough, because it's supporting the blades.
Correct, because anytime we need to bulk glass, it weakens it. So every time we virtually bulk to anything into a glass situation, we'll always toughen the glass because it will take the structural strength. The structural loads. Again, this is a typical what they used to call Pilkington used to call their Osfix system. It's really just a matter of spider fittings and fin splices, etc. This sort of thing. I haven't got a splice plate, but these sorts of fittings. Like there's a fitting that will get bolted to the glass, for instance.
With rubber back or just straight to the glass?
No, they'll have rubber. So you'd have, in this one you've got neoprene rubber. There would be, in the hole itself, you'd have some sort of hose or some sort of fitting, so the fitting doesn't actually touch the glass, because you can't have that. But the actual bolt itself is not doing anything except holding the two plates together. The plate and the suction from the rubber, that's what's doing the job. That's what's holding the glass in place. And to take them off, it's a really difficult job. This is a typical spider fitting type system, where you've got 4 spider fittings. Similar to that, but that's only got 2 arms to it, 2 spider. These are $300 each.
Wow. So
it's an expensive system. They wouldn't get any change from about 1,400 a square metre for that sort of fitting, that sort of system. That's the Tarek Winery. It's now the council chambers for Barossa Valley.
Wow.
That building. So it looks really cool with the copper urn or whatever it is in there. But now that's all gone. It's just full of dust and.
Oh, it's pretty.
It's disgusting. Yeah, it's disgusting. It's a shame because it's such a nice.
Yeah, because you can see obviously the whole glass box was actually built purposely for, actual.
For that.
Yeah.
Yeah.
And then to take it out.
Yes.
It's like that roof at Burnside Shopping Centre. As soon as the tree was gone, it was kind of like, what was the roof there for?
That's right. Yeah. We've just done a similar one down at the West End Brewery.
Oh, yeah.
The West End Brewery on, was it Port Road? Early Port Road?
Yeah.
And they've done the same thing. They put a copper thing inside, and it looks really cool. It does. That's the museum in Adelaide.
Ah, yes.
So here's the use of spice plates. You can see spice plates here, where the glass you couldn't get it long enough to do it in those days. So they had to join the glass together, so they use a splice plate to join the fin
to me
together.
like a spider fitting.
It's a spider fitting here,
Yeah.
and the fin has got to join there. And they had to use that, so they bolted the fin together at that point.
Got you. So that plate bit's called a spice plate.
It's called a splice plate. Yeah. I think there's a better photo of one here.
Yeah.
So
I actually quite like it as well. I mean, even though you said it's there for a practical reason, obviously, but it actually adds.
Yes,
I think it looks quite nice as a
Yes.
as a feature to the
Yeah.
glass as well.
Yeah.
You know.
Yeah, and then these slice plates have got caps on them, so they cover up all the bolts and everything.
Yeah.
We're going to get to SA Water, for instance.
Wow.
This is SA Water.
Oh yes.
You can see that the glass fins are much higher now because we can get glass bigger now than we could back in the museum's days. But you can see they didn't want the plates; they wanted a mechanical type look. So it's all bolted together. You can see there's 8 bolts in that splice plate. It's quite amazing.
It almost looks like sort of like the inside of a ship or something, doesn't it?
It
Glass,
does almost,
yeah.
yeah. And of course, SA Water, because buildings, the actual slab is cantilevered a fair way away from the building. So as people go to work, the building will sag. So this glass wall is designed to go up and down. So as people leave, the glass will go up, and then because it's fixed at the top, but it's not fixed at the bottom.
Oh wow.
Let's have a look. We got it. This SA Water again.
Ah,
You can see that's the footing for the glass fins. So the actual glass fin goes all the way down to there, but at the moment, if the floor is unloaded, it might be up there, the glass fin, and then as people load it, it moves down. So the
Wow.
facade
Gosh,
will move
that's
up.
quite clever.
It's pretty cool.
Mm.
And a big facade.
Mm.
These can go up to about. Before you need to tie them off to a slab, I think they can go up to something like. I'm trying to think. I know in feet. I'm trying to think in metric. 8-10 meters.
Wow.
About 10 meters, and then you need to tie it off somewhere.
Mm.
They're one of the few designs that actually survived the Kobe earthquake back in Japan several years ago.
Oh yeah.
And I remember watching a video of that earthquake, and someone must have had an early camera or something.
Mm.
But you can see the glass bowing, and because toughened glass will actually bow and spring back. Normal glass wouldn't. It would just shatter. It hasn't got any flexibility to it.
Right.
Whereas toughened glass will. EDS, the building's not called that anymore. It's the Motor Reg building now on North Terrace.
Oh yes.
EDS were the original tenants, and this design here used stainless steel fins with stainless steel rods
Oh yes.
holding the glass in position, which is and if you look at it, if you can get to the other side without getting hit by traffic, the actual spider web design of the fittings behind the stainless steel fittings of the stone, because they've secondary glazed it, is just really unique to Adelaide.
what do you mean by secondary glaze?
There's 2 pieces of glass. So you talked about Green Star before. The idea of a secondary glazing was to have a thermal chimney, so the heat would rise up through it, heat the buildings naturally. I don't know if it works properly, but it certainly was one of the early ones. It was built in the early 90s.
Wow.
The first time I'd ever heard of a thermal chimney was on this building. That's just a standard spider fitting at Moorfield Racecourse. As you can see, it's bolted to the steel comes out with a thread on it. They screw the fitting onto the thread and then bolt the glass to the
Wow.
spider fitting. So we do that with glass roofs. Generally only with glass roofs, but we don't see it very often with facades. That job there had countersunk bolts, like that one. But these days we don't tend to do countersunk bolts anymore. There's not enough point load there. We need a lot bigger point load generally on toughened glass. A point load meaning you would need to increase the size of
Yeah.
the pressure around the toughened glass. That's those fins again at SA Water. You can see that one's again with countersunk holes.
Yeah.
But nowadays we tend to not see that. We tend to see a big 50mm plate there and a bolt sticking out from it. When we consider glass and what thickness to use for a glass roof, we need to know what the span of the glass is. So the span of the glass is always a dimension between the supports. So it could be here and here, or it could be here and here. If it's there and there, then we've got a problem because all this is just cantilevered out and pretty flimsy. So it's generally opposite. They're generally opposite each other. Something along those lines. So there's a 2-edge supported glass roof at David Jones, again with spider fittings. This is all. It needs to all be engineered. It needs to be designed so that someone can walk on that glass roof to clean it or to clean the glass behind it. But it's not a trafficable roof. So a trafficable roof is actually a glass floor, something you're going to walk on all the time. But these are designed for a maintenance load, and that's all. I don't know if I'd want to walk on it though.
Yeah, you probably wouldn't want too many people at once.
No, they're generally designed to be about 120 kilos, and no more so either. The young blokes, the skinny ones.
Allow 20 kilos for your big bucket of water too.
Yeah, that's right. No, that's true. You got a big bucket of water up there too. You're right. So that's a bit of a closer view of it, and it's very similar to Morphettville, a bit more modern, but a similar way that it's been fitted to it. In those days, with David Jones, we could use monolithic glass in toughened in roofs above 3 metres, 5 metres. Nowadays, at above 5 metres, we have to use toughened laminates, and that's for that very reason I just said. But if it happens to break, if this glass happened to break, hit someone on the head, you'd be getting sued probably.
Yeah, it'd be pretty serious.
Yeah. So that's a close up again. That's probably Morphettville, I think. You've got the thread and how we just screw it onto that thread. The steelwork, the biggest problem we have is with the steel guys generally getting it right, getting it positioned correctly, and they do have difficulty getting those sorts of things in position properly. That's EDS again, the building I mentioned before. That's called ozone glass or slump glass. And slump glass is made all by hand. So all these panels are made, each individual panel is made by hand. They make that pattern, the pattern of the plane tree, which is the plane trees are all down North Terrace.
Mm-hmm.
They make that pattern in the sand. They scrape it out, make a beautiful pattern. They cook the glass to about 800 degrees or a bit more, closer to 1200. That then softens into the bed of sand. They wait for it to cool, take it off, and we're left with that.
Wow.
So it's a pretty cool system. So it's all handmade. This mob went broke. Ozone went broke a few 10 years ago. An Axel model, I've taken them over now. We don't see much of it anymore, but it's extremely expensive. But on EDS, there was no expense spared. The government just threw money at it. And that's the Sydney Canopy. It's near George Street somewhere. I found it when I was in Sydney once. But
I think I know that one. All right. Yeah. There's a lot of it. You got kind of brings you from George Street on one side onto the mall, doesn't
it's
it?
like a little.
So if you go through that kind of passageway, I think it brings you through to Pitt Street
That's
Mall.
right.
Yeah.
And I found it by accident. I thought, hey, look at this. I love it because of the labyrinth of steelwork in it, and everything's designed to go through into the spittoon here. So all the water runs off into the spittoon.
Oh wow, that's pretty cool.
So it's really interesting. You can see the labyrinth there of steel fittings. Okay. Now I can stop there. Or I can continue if you want. This talks about energy efficiency a bit and products and that sort of stuff. Do you want me to cover that for you?
Yeah.
We're involved in dealing with spandrel panels. So spandrel panels have I got a thing there? A spandrel panel is a concrete slab there. You've got a wall of glass. A spandrel panel fits in the middle there, so it hides the concrete from the outside. And generally what will happen is the builders will run their computer cables and their phone cables, and sometimes, if they're lucky, air conditioning ducts through there to the next floor above. Generally they have to be closed off for fire, which that doesn't show, but that panel there is called a spandrel panel. So
Isn't it the kind of frosty, kind of, sometimes you see it almost looks slightly kind of green in colour and kind of frosty. Yeah.
That's right. Have I got one?
Have you seen the new building on the corner of Hutt Street and South Terrace?
Hutt Street, South Terrace.
And it's got its
Augusta Towers.
But yeah, it's got its bum face to the city.
That's right.
and up the middle of it is all the service cabinets and the cabling.
Yep.
They needed to put spandrel panels
Yeah,
there
yeah.
because you can
Yeah.
just see cabling and whatever through it.
I don't know if that's finished yet, so
Oh, okay. Watch
maybe
this
still
space.
coming. Yeah, it might be. Our boss has bought a unit there, Augusta Tower. So they had to save the building in front,
Yeah.
which was heritage listed, and
Yeah.
they had to build behind.
Yeah.
Yeah. That's a spandrel panel there. So that's a building on Glen Osmond Road. It's the Nurses Federation, I think. So they used a black as a spandrel panel there.
Yeah.
You can do that, or you can do like they did on number 1 Anzac Highway, the old ETSA building there. They've used reflective glass all the way, and so they've used reflective glass the whole building, and you don't notice it's a spandrel panel until they turn the lights on at night, and then you can see where the blanks are. You can see in where the lights are, and where it's not lit, you can see that there's clearly a band of something happening there.
Yeah.
And that's similar there. Flinders Street, they tried to match the colour of the glass. The glass is a bluey green colour. They tried to match it with the spandrel, but personally I think it doesn't look that great.
Mm.
I personally would have had this a contrast. I think looks better than trying to match a colour that you're not going to be able to match.
Mm.
It never looks the same. The KPMG building on the corner of Peary and Pulteney, that doesn't use glass. That's a really easy system to use because the slab's just extended all the way out. They would run their computer cables underneath the ceiling, in the ceiling space, like you have here, pretty much. Under there. So just a different way of doing it. Very easy to glaze those systems though. All glazed from inside, you don't need scaffolding. It's much cheaper to do it that way. Glass performance. Is there any questions on anything so far? No? Okay. That was easy, wasn't it? We measure insulation by U values. So glass is measured in U values. When you buy pink bats, it's an R value, but in glass, it's called a U value. And it's a U value for several reasons because glass, a pink bat only has to stop the transfer of heat, but the glass also has to let light in. So U value is a better measure for being able to let light in, the refraction of light as well, the refraction of the heat. So we measure it in U value. Glass is a very poor insulator, very, very poor. So we're trying to do, a single piece of glass has a U value of about 5.8. So it's just a number. So you think it's just a number at this stage. If we double glaze it, it reduces that U value down to 2.7, so about 50% better. So double glazing certainly improves the insulation value. Nowhere near a pink bat, but still allows you to look out. And
So with the U value, the lower the number, the better performance,
the lower the better, lower the figure the better. Yes.
which is the opposite to R value, pretty much. Isn't it?
Correct.
Yeah.
Yeah.
The higher the better. The higher the number, the better the
That's
performance.
right.
Yeah.
Yeah, lower the number. The better. If you took that number and it's actually the reverse. So U value is the reverse of an R value. So that would have an R value of about 0.3 or something. So it's really quite low.
Right.
So it's still still doesn't insulate great, but you also have to be able to see out of it. So that's the problem. So I've got a 3mm clear glass, for instance. So we're talking about solar heat gain now. So solar heat gain, that means exactly that. So it's the amount of heat that directly radiates from the sun and goes through the glass and comes in the building, comes in the structure. So in 3mm clear, which is in probably 40-50% of homes certainly built before 2000, 9% of the heat is absorbed, 8% is reflected, so 8% is reflected away from the sun, 83% is transmitted,
Wow.
6% is emitted out, and 3% is emitted in. So the total, you're getting 86% of the solar radiation from the sun coming straight through,
Wow.
pretty much. So the solar heat gain is 0.86. So that means 86% straight in. So solar heat gain, the lower the figure again, the better. So you want generally you want a low solar heat gain on most elevations and a low U value.
And the emitted out and the emitted in comes from that if that's absorbed.
From the absorption, yeah, that's right. So when it absorbs heat, it actually emits it back out and emits it back in. Yeah. Just to compare performance, and you won't know any of these products, but in the double, and we generally sell. You know, we put a double glaze unit line in 2000 in Adelaide. It's the first time we've had one, and we only did it because of the airport upgrades for all the houses around the. That's the only reason we put it in, so that we could supply that glass. And we bought a second-hand line from Europe, and now we can't believe the number of double glaze units we sell. It's just gone through the roof. And Adelaide, we would never have thought that in the early 90s or even mid-90s. We expected to be able to do the job, do the airport, and then throw the thing away. But now we've changed our minds a bit. So you can see here, with clear glass, 70% of the solar heat gain goes straight through clear glass. So that's not a bad thing if you're facing south, or sometimes even if you're facing north. You want some of the direct sun coming in, heating your concrete up, and ambient, giving you passive heating. A really high light transmission. So great for, you don't have to turn your lights on in winter, but really bad if you want to try and work on your computer. So we don't go down the track. Grey is really good at you know, the solar heat gain comes down considerably, down to 0.48, 48% of heat in, but you lose your light transmission. With green, you virtually the same, but you keep your light transmission up.
Okay.
So green is ideal if you want high light transmission and low solar heat gain, or a lower solar heat gain. The U values don't change generally until we get to a product with a low emissivity into it. So a low emissivity glass is like stainless steel mugs, stainless steel flasks. It keeps heat in or keeps heat out.
Right.
So it's virtually got a stainless steel coating on it. So when we talk about that, it improves the gain. That 1.9 means it's about 65% better than clear glass at insulating at home. And we would sell 50% of our units now would have lower glass in them. And probably with argon gas, which insulates a bit better again. Because of the Green Star ratings, we brought this glass in, LOE 366, we brought that glass in from the States because it's the only place that was making those sorts of glasses back then when we first did it. The beauty of the 366 is it's got a silver coating to it, but it looks reasonably clear. It's a bit green, but it looks reasonably clear. It's got a 62% light transmission, which meets the criteria for Green Star, but a solar heat gain of 0.27. So only 27% of the heat, direct radiation, is coming in the structure, in the building. And a very low U value. It's probably as low almost as you can get with glass, at 1.35. About 75% better than clear glass.
And that's with air in the gap, not argon gas.
That would be with argon gas.
Okay.
Yeah, that's with argon gas. All of these low E glasses here all have a haze to them. So when you look out through them, you see a haze. And it looks a bit hazy. A bit like your car windscreen when it's got a bit of a film on it and it's driving into the wind, into the sun. The beauty of 366 is it doesn't have a haze. So we're finding a lot of people are buying it just because it doesn't have a haze, because they hate the hazy look of the glass.
Yeah, I've just got double glazing in mine because mine faces west, so I got double glazing with argon gas.
Have you?
Yeah.
Yeah, okay.
It's got like 2.6 meter high bifold
Right.
put in. Yeah, and
So just clear glass, eh?
yeah, I think so.
Okay.
Yeah,
The
because I
problem
had,
with clear glass is you're still going to get a really high solar heat gain on the west elevation. So it's not doing a lot to stop the summer sun from actually coming through.
yeah,
And sometimes that's not a great thing, because once it's in, because it's a double glaze unit, it'll keep it in. Doesn't want to get it out.
Well, I've got the same as Joe, and tall, very tall,
Yeah.
but mine's north facing. But what I did was, because I wanted the winter sun to come in, I didn't want to put a reflective. I put a polycarbonate 99% UV filtering
Yeah.
veranda out there.
Yeah.
and it works very
Yeah,
well because
okay.
if the sun doesn't strike the glass,
No.
you know, so it doesn't get in under that
Sure.
UV filter,
Yep.
it seems to work very well because
Yep.
otherwise the sun's hitting the glass,
That's
in the
right.
glass through the polycarbonate, but it's not heating it up anywhere near when it does hit the glass. It's
Yeah.
double glazed argon,
Okay. Sure.
clear.
Yeah.
Yeah.
With the north, ideally, what you want is you want to stop that summer sun.
Yeah.
Not so
So
much.
you want the winter sun.
You want to get the winter sun in. So you want to allow the winter sun in
Yeah.
when it's lower in the sky.
So it
And when it's
does.
higher in the sky,
Yeah.
you want to stop it.
Yeah. So it dips in under the polycarbonate
Yeah.
winter.
Comes in winter.
In the shoulder, March and October is the problem. It does get
Yeah.
in under on the west.
That's right.
From the west, and it hits the glass, and then
Yeah.
it does hit the
That's
glass.
perfect. Yeah.
Yeah, but
Yeah.
it's as best as I can do.
Yeah. Yeah.
Yeah. But I'm with you, Joe. It's nice.
He's nice.
That's 366. That's the Riverside Cafe near the Festival Theatre.
Oh, yeah.
Just at the end of the bridge. So a really clear glass that's actually keeping that heat, a bucket load of heat out, and insulating really well. So it's perfect for those sorts of scenarios. Sometimes it looks a bit green. That one there looks really clear. And other jobs we do, it looks really a lot greener. So it just depends, I think, on the lighting and where you are and what time of the year it is and that sort of stuff. Now again, this is a video. This is switchable glass. And again, I don't know if it's going to work, but we'll give this a go again.
Have you seen this
Yeah,
operation?
I was in Hong Kong 10 years ago and they used this one in the bathroom.
No, you have to know the operator.
Yeah, you can do it for the bathroom window, isn't it?
I don't know, it doesn't work. Where is it? No, it's not working.
Then the switch.
It's got a switch. So you switch it.
Yeah.
And especially a light switch. You switch it and it goes clear.
Yeah, and
Yes.
then fogging.
You switch it off and it goes. Switch it off and it goes clear. You switch it on and no, the other way around.
Yeah.
You switch it on and it goes
Frosted.
frosted.
Yeah,
Mhm.
frosted.
That's right. No, you switch it off and it goes frosted.
Ah.
You switch it on and it goes clear.
Right.
Just in case of the power failure.
Yeah.
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 Ah, right. Yeah, that
And,
makes
and
sense.
so, what is in that glass to make that happen?
It's got a series of diodes, so hundreds of thousands of diodes are inside the actual interlay. So in the PVB interlay, they actually impregnate the diodes or the lights. So so that's what activates it. It's a strange product to work with. We've never done it ourselves because you just need to press on the interlay, and you damage one of the diodes, and then you get the yucky marks.
Yeah.
So it's a pretty cool system. Really expensive,
Yeah.
like $3,000 a square metre or something. So it's that one's a curved one as well, so that would have cost a bucket.
How much they salary?
Yeah.
This was the owner. This bloke was the chap was the owner of the Lucky Jackpot pubs.
Ah, okay.
So he had 4 or 5 of them.
Hmm.
He died not long after he built it. So it's a shame. And he got a great view. So that's that is a magnificent view through there on his property at Torrens. Torrens Park. Other things
Okay,
that we play around with is we can laminate red or any colour from the Pantone colour range. So
Right.
in the case of Kmart, they couldn't find anybody else in Australia that could actually give them their colour. They wanted PMS 32, which is their colour, and we said no, we can do that. So and we did, because they stuck fluoros behind it, which is really horrible. So they should have had LEDs or something all over it, or something different than that.
Mm.
But anyway, it's something that and they loved it, but they've never done it again. So I don't think I think the fluoros turned them off.
Oh wow.
That's a splashback. So this particular person wanted the forest as a splashback. I'm not sure. No, it's a splashback behind the kitchen. So it's their favourite photo they've ever taken or whatever, and they just give us the file and we can laminate it between the glass.
Wow.
So I don't know how you go shoving the house with that, but anyway, I guess you can change it.
Yeah, it's very personal taste. I mean, it looks
It is.
good, but
Yeah.
it might date and then obviously trying to sell the house. Yeah.
Yeah, I think you raindrops there on the red. No problems doing that. It looks really good. It looked really good when we first did it. But again, I think it would date pretty good.
Yeah.
Oh, I've got another one. Maybe that one's a little bit better, a bit abstract.
Yeah.
But we actually did one with for a couple. They love Paris. They got all these photos of Paris, and so they did a collage. Is that right?
Collage, yeah.
Collage of Paris, photos of Paris, all over it. And I thought, oh, that's going to look awful. And it looked awful when we made it, and they sent it out. When I went to the job to have a look, it was just spectacular. It was just spectacular. It was a beautiful kitchen as well, which probably helped. Yeah. That's us done. That's our factory. That's just part of our factory where we store a bit of stuff. But we're done.
And where's your factory, Peter?
We've got two factories. So we've got one at Melrose Park, and we do most of our heavyweight toughened is done there. So shower screens, most of the glass facades are all done at Melrose Park. They've got the water jet cutters to cut the glass and that sort of gear. At Royal Park, the other factory, we do double glazing, we do custom laminating and toughening. We do toughening at both plants. So we're the biggest glass producer or glass processor in Adelaide.
With the mobile and the demountables and stuff, there's nothing special around the glass there, is it? Because in transport, just the same old glass. Yeah,
glass gets broken, they replace it. Yeah, you're right. It doesn't travel well often, but
I wondered about that. I suppose they put tape across and whatever. Yeah. The other thing was with your window frames. It's interesting. So you make the glass and the window frame because you don't make it like you process.
We don't make the window frames. We only process the glass, and we sell it to people like Dow, Steg Bar, and those sorts of companies.
And then they make the frame.
And they put the frame in the store.
Okay.
Anyone got any questions? Yes?
No?
Well, going back to the Green Star. So, a controversial system. I understand the rating.
Yeah.
But that one particular glass, if someone puts that into that building, they can obviously make a statement that it contributes towards their.
Yeah. I don't. You know a fair bit about the Green Star.
No,
you don't. Okay.
It's enough to be dangerous. Yeah.
And I'm the same. I'm enough to be dangerous too, but they have a series of points. So if you achieve 62% light transmission, you get 70 points for that. If you have a bus stop out the front, you get 70 points for that. If you meet other criteria, the insulation values and the carpeting, the floors, etc., and the lighting, you get points for all those sort of things. So it's a series of points, and at the end of that, you get your Green Star rating.
And you have to get a 4, 5, or 6 to
something
say
like
it's a Green
that.
Star building.
Yeah, that's right.
And presumably that helps you get tenants and whatever. But with sound insulation, which is interesting because you said you put the double glazing in originally for sound management because of the airport.
Yeah.
Have we ever had triple glazing for that reason? Or
We can. Yeah, we can. We don't triple glaze much in Adelaide, but we can.
Yeah. The idea is obviously the air gap is what deadens the sound.
Pretty much. Double glazing doesn't do a lot for noise. If you just had 3mm glass and 3mm glass with an airspace, you'd be better off putting a bit of 6mm glass in.
Yeah.
That would give you a better sound rating.
Yeah, okay.
Because the body of the glass would actually is thicker and it's tougher to get through.
Yeah.
So with the airport job, that was thick laminate on one side and a thinner laminate the other side. So the laminate giving you the laminate being the PVB actually gives you some sound attenuation, so it reduces the noise. And having two different thicknesses makes the sound wave. Every time the sound wave hits something, it actually changes its frequency. So as you go through two, and they're different thicknesses, then it reduces again. So that's why they come up with two different thicknesses of glass, and it generally works better.
So that's what was probably here as well from a sound transmission for partitions and
You've just got 10mm lam here, I think. Okay. 10mm laminated glass. So this 10mm laminate does a reasonable job. It stops about 35 decibels of noise.
Because of the lamination.
Because of the lamination and the thick glass.
Yeah.
So the double glazing doesn't do it generally.
And so how much does it stop normally?
About 38 decibels, 10mm laminate.
Oh, wow.
So if voices are about 45 or 50, you very rarely hear noise through it.
Oh, cool. It's good to know.
Yeah.
Excellent. Okay. Cool.